ions. Think now, ions. We discussed ions. We discussed ions in the previous classes, but from the idea of ions, we'll move into oxidation number. So let's discuss ions first. An ion. What's an ion? Huh? Sorry? Alright, ions are elements or compounds that contains electrical charges. Ions are elements or compounds that contains electrical charges. And of course, in our previous class, the difference between a positive charge and what? A negative charge. If it's negative, what does it mean? It's gaining electron. If it's positive, what does it mean? It's losing electrons. Think of it. There are two types of ions. 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 We have monoatomic ions and polyatomic ions. Alright? The monoatomic ions. There is the polyatomic ions. When you hear the word monoatomic, it's clearly defined. What's mono? One. Atomic, atom. Alright, so think of this. Monatomic ions are ions of just an atom of an element. They are ions of just an atom of an element. Ions of just an atom of an element. Example, O2 minus. Yes, monatomic. H plus, monatomic. Na plus, monatomic. Cl minus, monatomic. All of these are what? Monatomic ions. Why? Of course, you can see they are just of one atom of what? An element. Let's look at polyatomic ions. Look at polyatomic ions. These are ions made up of several atoms joined together. These are ions made up of several atoms joined together. Full stop. They can also be defined as the ions of compounds and radicals. They can also be defined as the ions of compounds or radicals. Example, you can see this now. Here's an ion. Why? It has a charge. Well, it's polyatomic. Why? Because it consists of what there? Various atoms. So here's the polyatomic ion having one atom of nitrogen and what here? 3 atoms of hydrogen. Here's a polyatomic ion having what there? 1 atom of what? Oxygen and what in here? 1 atom of what? Hydrogen. Alright? Concept is this now. The ions of elements are said to be monoatomic. The ions of compounds or radicals are said to be what there? Polyatomic. That's the case there. Alright, let's look at something called oxidation number. Let's look at oxidation number. This is defined as the actual charge. This is defined as the actual charge of an atom. This is defined as the actual charge of an atom if it exists as a monoatomic ion. The actual charge of an atom if it exists as a monoatomic ion. Full stop. Summary please. Rules for assigning oxidation number. Rules for assigning oxidation number. Rules for assigning oxidation number. All right, number one. The oxidation number of an element is equal to 0. Number one, the oxidation number of an element is equal to 0. Number two, the sum of the oxidation number of the individual elements of a compound, the sum of the oxidation number of the individual elements of a compound is equal to 0. It's equal to 0. Number 3. For a monoatomic ion, the oxidation number is equal to the charge. For a monoatomic ion, the oxidation number is equal to the charge of the atom. It's equal to the charge of the atom. So we are saying this case. For this, okay, let's do first. Right, number 4. For a polyatomic ion, the sum of the oxidation number of the individual elements, in the compound is equal to the charge of the polyatomic ion. Is equal to the charge of the polyatomic ion. But what now? Number 5. The oxidation number of halogens is -1. The oxidation number of halogens is -1. What are halogens? Your group 7 elements: chlorine, fluorine, iodine, bromine, right? And all the names you can see. Number 5. The oxidation number of the halogen is equal to -1. So we'll end with this one. Number 6. We'll end this one here. Number 6. The oxidation number of oxygen is -2. the oxidation number of oxygen is -2. You there? The oxidation number of oxygen is -2, except in peroxides. Where it is -1. Except in peroxides where it is -1. Let me just explain what I've just said. So look at it. We know this concept in naming compound, but then know this 6 or 7. What I give them? Know this basic rules. Number 1, if I'm having just a compound. Now, by the way, what's the difference between this and then this? What's the difference? Let's call this ABC. So here's my A, here is B, here is C. What's the difference between ABC? What's the difference? What's A? What's B? What's C? A is H, B is H2, C is H plus. What's the difference? A is an element, B is what? Compound. B is what? Compound. And C is now what there? An organic compound. What's the difference between A, B and C here? Sorry? C is an ion. Fine. What next? Huh? Right, so since I'm on record, let me save time. A is actually what? An atom. B is what? A molecule. C is what? An ion. That's it. Right? So what you have is actually what there? An atom of hydrogen. What you have is what? A molecule of hydrogen. Now mind you, hydrogen is actually what there? Diatomic. That means in a molecule of hydrogen I have what there? 2 atoms. That's the concept. This is because of there an ion of hydrogen. Now back to what I was saying. If I had a compound like this, NaCl, sodium chloride here. For sodium chloride, the oxidation number of this, okay, I started with elements first for compound. So let's start with elements. Let me say I have just Cl. This is chlorine. In this case now, the one says the oxidation number of an element is 0. So here is just a simple element, is 0. Number 2 says that the sum of the individual, or the sum of the oxidation number of the individual element that makes a compound is equal to 0. If I have NaOH in this case here, if I do the sum of the individual elements, that's sodium, oxygen, and hydrogen, if I sum them up, it's equal to 0. That's rule 2. Rule 3 says that for a monoatomic ion, that the oxidation number of a monoatomic ion is equal to what there? The charge of the ion. Hence, the oxidation number of chlorine becomes what there? -1. The charge here is -1. Alright, so the oxidation number, get this right, please. The oxidation number of chlorine is 0. The oxidation number of chlorine ion is what? -1. What's the difference? Number 4, we said for a polyatomic ion, something of this nature, we said that the sum of the oxidation number of the individual elements is equal to what there? The charge of the ion. So the concept is this: if it's just an element or a compound, it's equal to 0. If it's an ion, it's equal to what there? The charge of the ion. That's the concept. Then what was number 4 there? For halogens, it's -1. So fluorine, right? Fluorine is minus, chlorine is minus, iodine is minus, all your bromine, all your halogens, we have -1 as oxidation number. Next up, for oxygen, we said the oxidation number of oxygen is what there? -2. There's an exception, except the what there? Peroxide, where is what? -1. I'll do that proof for you. Take this stuff down. Let's do some calculation. Take this down, please. The oxidation number of some of the important element. Alright. So I was saying this, we said the oxidation number of some of the important first 20 elements includes, so if it was your word now, I'll give you the first 20, all of them. This is Jamb. I won't give you first 20, I'll give you the most important ones. Includes number 1, hydrogen plus 1. Number 1, hydrogen H plus 1. Number 2, beryllium Be plus 2. Beryllium Be, that's plus 2. Oxygen O minus 2. Sodium Na plus 1. Magnesium Mg plus 2. Aluminium Al plus 3. Potassium K plus 1. Calcium Ca plus 2. Plus 2. Alright, so these are like the most important ones to me. There are still others for the first 20. When it comes to year 1, if you meet, I'll give you for the first 20, right? I'll show you some of them have what's called varying oxidation number. But until then, let's focus on what you have there. So with that concept now, let's say we are asked to name a compound of, let's start with something easy, compound of this nature. I'm asked to name this compound here. Alright, so I want to look at how to name compounds using the oxidation number state. What do you do here now? I will introduce the oxidation number. Before you use the oxidation number now, you have to first of all identify which element is being oxidized. Usually, the oxidized element is simply the element that appears before oxygen, that's all. So in this case, I'm seeing 3 elements here. There's calcium, there's carbon, there's oxygen. The oxidized element here because what there? Carbon. Why? The element before what there? Oxygen. Now when it comes to oxidation number concept, that oxidized element is taken as an unknown, call it X. So in this case now, this now be equal to, we said calcium is what there? Check the oxidation number. What's calcium there? Plus 2. That's the last one we got there. Plus 2. It becomes for calcium, that's 2 or plus 2 if you want to. Plus, this becomes my oxidized element. I said, assuming to be what there? An unknown. So it becomes what there? X. Plus, next up, I'm having oxygen. Check. For oxygen, what do you have there? Minus 2. So it becomes minus 2. If I look at this case, how many atoms of oxygen do you have here? It becomes times 3. Check your rules for assigning oxidation number. We said that the sum of the individual oxidation number of compound is equal to what there? 0. It's not an ion. Compound is equal to 0. Get X here. Some people don't like solving. I wonder how you know it from solving. Still here again. Get X here. What do you get it now? 2 plus X plus minus 2 times 3, that's 6. Is equal to, minus 6. There's nothing that happened. What you talking about? I don't like solving. Some people make mistakes. Anyways, let's proceed. So please see what here? Minus 6, right? Let's proceed. So I guess what's here? 2 plus X plus minus 6 equals to 0. I'll take this 2 here. So I'm having X 2 minus 6, you see what there? Minus 4 equal to what there? 0. Move forward in front of there, plus 4. So X is equal to 4. What does it mean? It means that the oxidation number of carbon here is what? Is 0. How do you name this compound? Listen, start from this one here. What do you have there? Calcium. becomes calcium. From here, please skip the oxidized element. I'm skipping this. I'm coming to this. What do I have now? Oxygen. How many oxygen? 3. So because of that, try for 3. Trioxygen. 3 trioxo. So calcium tri, that's 3. Oxo, 3 oxygen. Next up, here is carbon. Don't say trioxo, carbon, no. Alright, there's something called an 8. Usually, when elements are combined with oxygen, gives you what there? An 8 of that element. Carbon plus oxygen, carbonate. Sulfur and oxygen, sulfate. Fluorine and oxygen, fluorate. Have you? This one 8 of the compound. So having carbon and oxygen gives you what there? Carbonate. Carbonate what? What number is here? The 4 will be Roman numeral. So having these compounds, calcium trioxocarbonate 4. That's the compound. This is how you name compound using oxidation number concept. Right? So simply find the oxidation number of the oxidized element and then do your maths. That's all. Do your maths. That's all. Copy them, let's try this one. I'll give you the simple ones now, right? Look at the complex one, much more later. Just relax. Look at this. H2SO4. The usual acid, you know. Usual acid, you know. Let's get this one done. Alright, first things first, calculate oxidation number of the oxidized element between hydrogen, sulfur and oxygen. Which of them is oxidized? Obviously sulfur. Why? The element of oxygen. So hydrogen there, if you check, what's the oxidation number of hydrogen there? Is it +1? Right? So I now have this one there, 1. How many atoms do I have there? 2. Because what now? Times 2. Plus, I'm now here with my oxidized element, call it what there, and unknown X becomes X plus, next up, oxygen, that's what there, -2 becomes -2 times, how many atoms here? 4. This now is a compound, not a atomic ion. So now this is equal to what there? 0. The sum of the oxidation number of each of the elements in the compound is equal to 0. Work this out. This gives you what here? 2 plus X plus -8 is equal to 0. Having 2 plus X plus -8 equal to 0. This and this, I'm having X. 2 minus 8 is -6. Equal to 0. Move this over here. X is equal to 6. Name this hydrogen first. I said skip the oxidized element. Take this and this because of there. If it's 3, it's trioxo. If it's 4, because of there, tetraoxo. If it's 2, what do you call it? 3, 4, 5, penta 6, hexa 7, hepta 8, octa 9, nona 10, deca 11. 11 is on deca. 12 is what? Dodeca. 13 is what? Trideca. It's following that what we call a French on neutral, right? Yes, okay. Whichever way. So it becomes hydrogen, 4 is tetra. It becomes tetra, of course, the oxygen, that's oxo, Carbon, oxygen, carbonate. Sulfur, oxygen, sulfate. Gives you sulfate. Sulfate what here? 6. What is the Roman numerals? VI, Victoria Island. VI, right? That's the name. Let me test you with one. You know, as I say, the tests you always. I will solve examples and give you problems, right? Let's try this. Let's see if I can get this answer again. Alright. So, question is this now. In this kind of compound here, I said, first of all, identify the oxidized element. In this kind, I said, usually, the oxidized element is the element of oxygen. The one with oxygen. This one here, what's the oxidized element? Is it calcium or chlorine? Huh? Calcium or chlorine? Chlorine. This is chlorine. Right? It's chlorine. But when it comes to oxidation of elements that are inside the bracket, what's your first task? Your first task is to expand the bracket. Expand the bracket. If I expand this, what do I get here now? Ca, this 2 comes this way here. That gives you what there? O2. These 2 come to Cl. That gives you what there? Cl2. So I have this. In this case now, my oxidized element is now which one there? It's now chlorine. It becomes X. Right? So please didn't continue the questions here. How do I solve this? For calcium, what's the oxidation number there? +2. That gives you 2 plus. For oxygen, what's the oxidation number? -2. -2 times how many atoms here? 2. That's 2 plus. For chlorine is my unknown. What do you call it there now? X. Becomes X. But before then, how many atoms does it have? 2. Becomes X what there? That 2 equal to what there? 0. X times 2 equal to 0. Work this out. This gives you 2 plus -4 plus 2x equals 0. Take out brackets. 2 plus minus -4 plus 2x equals 0. That one gives you 2 minus 4 minus 2 plus 2x equals 0. Move this one over here. I have that 2x is equal to -2 comes in because of there plus 2. Divide this side by 2. Divide here by 2. Divide here by 2. This cancels. What does it mean here? X is equal to what there? 1. So particularly see 1. How do you name this? This is now this one here. Calcium. Is it a diazo? Is it diazo? Now mind you, if I expand this to this means diazo. But when it comes to naming, you name it from its original form. From its original form, was there 2 oxygen here? It becomes what there? A mono-oxo. Or better still, just an oxo. So calcium oxochlorine. And because of that, chlorate what? That's it. Calcium oxochlorine. this is how we find the oxidation number of this and see if you can read it. Let's look at this. We'll try 2 more examples. 2 more examples. So yeah. Let me show you something. Try 2 more examples. I'll work on this. So here's what the task is. For this now, which of them is the oxidized element here? Huh? Look, this is chrome. It's not really chrome, it's overmeaning. I don't know what overmeaning is, I'll call it PH. Is it PH brother? Chromium, not chrome. Alright, so it's actually chromium, right? So chromium becomes my oxidized element in this case. Alright, so what we do here now, we call this one X, the unknown, since it's now the oxidized element. This becomes X times number of atoms 2 plus oxygen. Oxidizing state is what? Minus 2 number of atoms 7 equal to what there? 0. Have it? Who say yes? No. Why? Here's a polyatomic ion. I stress this. This one is now an ion, not just a compound. This one is a compound. It's equal to 0. For an ion, because of there, the charge of the ion. That's it. What's the charge here? Minus. Is it minus or 2 minus? I explained this the other day, I think it's actually minus 2. Write it as what? 2 minus to avoid what? That confusion. I explained this in the previous video. Same video. Previous class. Well, that's my YouTube guys, you will understand the previous video because they're watching videos. So. Alright, so it becomes equal to minus 2. Alright? So what is that? Let's see what here. 2x plus minus 14 equal to what there? Minus 2. So I'm having this as what here? 2x plus minus 14 equal to what there? Minus 2. Move this minus over here. I'm having 2x is equal to minus 2. So it becomes what there? Plus 14. So I'm having 2x is equal to, this gives you what there? Plus 12 or 12 minus 2 plus 14 is 12. Right. Divide here by 2. Divide here by 2. This cancels this. X is now equal to 6. Please help me out with. How do you name this? How do you name this? Yeah? How do you name this? Yeah? When it comes to, see, sciences, there's an error they do in secondary school. The error is this. They say if you're smart, go and do science. If you're not smart, they say they recommend you for art. But that's actually an error. Because science students actually dull ones, while art students usually smart ones. I think it goes that way. What am I saying so? Science is easy, it's just copy and paste, copy and paste. Are you smart enough to copy and paste? The same rule works for everything. Just like mathematics, the principles are the same, you don't have to graph. Whatever you do in mathematics is always either addition, subtraction, multiplication, or division. I've never seen a math in this world since I was born that a kind of math that is above either addition, subtraction, multiplication, or division. Even your calculus. Calculus is either your even when you're taking square root, square root is simply what there? Multiplication. Root 4 is equal to 2. Why 2? Because 2 times 2 gives you 4. So everything revolves around that stuff. So science is usually know the basics and then go out from there. How do you name it? Let's assume you saw this man in an exam for the first time. Say name it. What do you do? Go back to what we know. What we know, when it comes to naming, how do we pull up the naming? I said name your first compound first. I said leave the oxidized element for what there? For the last. So I said. In this case now, what's my oxidized element? Chromium. Leave it for the last. So I will name this one now. There's nothing here for me to say sodium and no. So leave that one there. That is one will come last. So name this one first. This becomes oxygen. How many of this here? So 7 becomes what there? What's 7? Hepta. So it becomes hepta oxo. Suppose say dichromate. Okay? Hepta oxochromate. What's there? 6. Ai. Of course, this is an ion. So put what there? Ion. So put ion there. It's an ion. Or those they put atomic ion. It's an ion. It's called hepta. Alright. I have to bring some up here. So this one is somehow. So usually, if you check our previous examples, we've done naming of compounds for stuff like this that has, this one has 2 elements. This one has 3 elements. 1, 2, 3. Our previous example also has what there? 3 elements. What if I have 4 elements like this from the compound? What if I have 5 elements from the compound? What if I have 6 elements from the compound? How do you name it? How do you name it? Alright, so task 1 would be to calculate the oxidation number of the oxidized element. Between sodium, hydrogen, phosphorus, and oxygen, which one is oxidized? Obviously the key here, phosphorus. Why? The element for oxygen. Alright, what's out? So when it comes to sodium, what's my oxidation number for sodium? +1. Confirm that. +1 times how many atoms there? 2. Hydrogen +1 or just 1. This becomes oxidized element. That becomes what there? X. Plus oxygen becomes what there? -2 times how many is equal to -1. Have you? Equal to what? 0. Equal to 0. Equal to 0. Observe, it's not an ion. It's 0. What is that? What do you get now? 2 plus 1 plus x plus -2 times 4 -8 equal to 0. What is out? This now gives you what here? 2 plus 1, that's 3, plus I have x plus -8 equal to 0. So this now gives you x. 3 minus 8 minus 5 equal to 0. What's x here? X is equal to -5 comes here, becomes +5. Name this. How do you name this? So name what? This thing you name. Let your conscience tell you. Is it correct? No. I don't want to go to you. Let your own conscience. Do you think it's correct? Alright. Listen. The only one that comes with 8 is the one that oxygen is holding, right? Chromate, because it's combined to chromium or oxygen per se. Chlorate, why? Combined with oxygen. So the one that changes, the only element that changes its original name is the one combined with oxygen. Aside that, everyone retains its original name. So because of here, so sodium. Next up, hydrogen. Sodium, hydrogen. Oxidized element. Leave it for last. Because of now, tetra of what? Phosphate. Phosphate what there? 5. That's what the compound is. Sodium, hydrogen, tetraoxophosphate 5. That's the name of this compound. So we are passing this part now. Done. Let's do something else. So please don't start saying CO3. I want to say CO3 this class again. So I give you the name and I'm gone. Like, please give me this name. NO3. PbNO3. Give me this name. PbNO3 2. What do you get? let's save time. Let's save time. How do you get this one? How do you name this? So look at this. How do you name this thing? We talked about elements having varying valency in the previous class. We used copper, for instance. Copper is 2 plus, 3 plus. We use chromium. We have chromium 2 plus, 3 plus. We also mentioned lead. Lead has a varying oxidation state, that's plus 2 or plus 3. In this case, I'm giving this question now. How do I know it's like 2? Or how do I know it's like 3? It's easy. Use a concept of valency. We said if a compound is X, A, Y, B, what does it mean? It means it's now equal to X. This part is supposed to be here. That's B plus what there? Y is here. A. They will exchange parts. So we said. So in this case, what does it mean here? From having PB, then NO3, 2. What does this mean? This means PB, that's lead, is combined with NO3. Get their part. Obviously now, B went to this, so 2 will go here. Of course, lead is always positive, that's PB2. NO1 there, 3 minus. I gave you this radical in your notes. Check, it was in your notes. When I give you radical, that means you didn't read this stuff. When I give you valence, I think I give you this. Right? Yes. So this is because of that, like 2. So you shouldn't be asking me what's the solution number. You should know that's 2. Alright. So this is 2. What do we get here? PB NO3 2. Expand this bracket. Becomes what here? PB 2 here, N2, 3 here, 3 2 6. We have this. Right. Put in oxidation number. This one there is like 2. So I'm using 2. If it was 3 here, because of there, like 3. So it's 2 here. I'm putting 2 plus. Here's my oxidized element. I'll call it X times 2 plus oxygen is minus 2 times number of atoms 6 equal to 0. Work this out. I'm having 2 plus this and this, 2x plus this and this, minus 12 equal to 0. Take off the bracket. I have 2 plus 2x plus minus 12 equal to 0. Take this and this. I'm having 2x first. 2 minus 12 minus 10 equal to 0. 2x is equal to 10. Divide by 2, divide by 2. So it means that x is equal to what there? 5. So I have this. How do we now name this? When it comes to the naming, I said, I'm having elements such as lead, copper, chromium, having varying oxidation numbers, varying oxidation number. It's important you indicate the particular ion you use. In this case, for the lead, was it lead 2 or lead 3? Because lead in bracket 2, then called trioxynitrate. How many here? 5. Complete. Not just lead, 1 and 2. But